One of the very important concept under the Fermi concept we require to understand is effective mass of an electron of or electrons. Now what is the effective mass of the electrons? Let us try to take a metal and try to apply an electric field. Naturally, due to the electric field, electrons are being drifted in a direction opposite to the direction of the electric field. This is the direction of the electric field. Classically, what we observe is that every electron that is going to move or they are able to drift only because of the presence of the electric field externally applied. But quantum mechanical, if you observe, every one electron also have some kind of influence over the neighboring electrons. There is a reason that every one electron also has an influence not only outside but also due to the electric field of the neighboring electrons. Therefore, the mass of an electron to be represented as not m, it should be represented as m star. And m star is simply nothing but it is the effective mass of the electron, and this effective mass is mainly because of the electric field acting on the electron not only due to outside but also due to the neighboring electrons. If this is the case, how do we able to modify the expression for the conductivity of metals? Wherever, according to the classical free electron theory, the conductivity is being given by n e squared tau divided by m. This is what the expression for the conductivity of metals according to the classical free electron theory. Now here, what is tau? What is tau? Tau is the relaxation time. By definition, velocity is equal to distance by time, or time is equal to distance by velocity. Now here tau also is the time, therefore it is the distance traveled. The distance travel is being represented as lambda. This is called mean collision time. This is called as a mean free path. That is a path traveled by an electron between the two successive collisions divided by the velocity. And let us consider only at the Fermi, that is the Fermi velocity. Therefore, this above equation I can represent as n into e square into lambda divided by Vf here into m, but m I will try to consider as m star. So, the quantum mechanical concept replaces the classical equation as n e square lambda divided by m star into Vf. This is what the expression for the conductivity of a metal, or the reciprocal of conductivity is nothing but resistivity, which I can write as m star into Vf divided by n e square into lambda. This is the expression for the resistivity of a material. Now based on this expression, let us try to observe that how the failures of the classical free electron theory was explained based on the quantum free electron theory, and that is what we write as the merits of quantum free electron theory. What are exactly the merits? We have observed two things in the classical concept. The one concept according to the classical theory we observed is that sigma reciprocal to the square root of the temperature, and second one is the sigma directly proportional to n. These are the two drawbacks of the classical free electron theory. Let us see whether we are able to explain this based on the quantum free electron theory. Now to understand that sigma, we know that it is going to be n into e square into lambda, it is lambda divided by, this is lambda divided by m star into Vf. That is the expression we have. Just now we have come across. And from this, see, at the Fermi level, let us consider at the Fermi level, velocity is independent of the Fermi, because Fermi velocity is independent of the temperature. Fermi energy is independent of the temperature. M star is not going to depend. The only one thing that sigma is depends on is exactly lambda. Therefore, at any given temperature, sigma is only depends on lambda, and it is independent of n, independent of E, independent m star, and independent of Fermi velocity. So it only depends on lambda. Now how do we able to explain? Lambda is the mean free path. Let us try to take an electron. At absolute 0 Kelvin, electron is at rest. But as I increase the temperature, the electrons start vibrating from its mean position. So it is going to occupy a certain area. Therefore, I can very clearly say that As the temperature increases, the area also going to increase. But as the area increases, what exactly going to happen? The distance traveled by the electron, it decreases. Therefore, I can say temperature is reciprocal to lambda. From the above equation, sigma is proportional to lambda, but lambda is reciprocal to the temperature, which itself is the actual theory. There is a reason that the actual theory can be explained only based on the quantum free electron theory, where in the case of classical free electron theory, the vibrations of these lattice ions or the electrons are not been considered. That is the reason that classical free electron theory failed, but that has been taken into account. There is a reason sigma is reciprocal to the temperature. This is one of the success of the quantum free electron theory. And what is exactly the second? The second thing is the sigma proportional to n, where classical free electron theory says that aluminum is the best conductor, zinc is the next conductor, and then the copper is the conductor. But in an actual practice, copper is the best conductor, aluminum is the next conductor, zinc is the next conductor. So how do we able to explain the conductivity of any given material based on this? Now to understand that, once again let me come back to the equation. Sigma is equal to n into E square into lambda divided by m star into Vf. This is what the expression. Naturally, sigma is proportional to n, no doubt. But E is a constant. It depends on lambda and it depends on Vf, because m star is also assumed to be constant. However, m star need not be always considered to be exactly a constant. Therefore, I can say sigma proportional to n lambda divided by m star into Vf. Now, let me try to consider sigma for copper. I can say sigma for copper is proportional to number of electrons of the copper, lambda of the copper, m star of the copper, and Vf, Fermi velocity of the copper. Similarly, I will try to take the expression for sigma of aluminium. You try to consider the number of electrons in the case of aluminum, because they are not the same. The lambda is also not the same. M star, where for aluminum there are more number of electron, influence is going to be different, and the Fermi velocity, it is also going to differ. Therefore, I can divide those two equations, sigma of copper divided by sigma of aluminium, which is equal to, if I try to divide, of n of copper divided by n of aluminium into lambda of copper divided by Vf of copper, both are copper, divided by lambda divided by Vf of aluminium into m star, they are reciprocal. Therefore, m star of aluminium divided by m star of copper, We know that number of electrons in the copper is lesser than the number of electrons in the aluminium, where number of electrons in the aluminum is almost equal to 2.13 times greater than the number of electrons in the copper. So classically we had only this into consideration. There is a reason that aluminum was a better conductor than that, but we have not taken into account the other factors. But if you really see lambda by Vf of copper, which is almost 3.73 times greater than the lambda by Vf of aluminium, this product is much greater than that. And not only that, the m star of aluminium here and divided by m star of copper is also have a relation of around 1.08. That means m star of aluminium is 1.08 times m star of copper. Naturally, if you try to take all these three into consideration, sigma of copper is greater than sigma of aluminium. This is how the quantum free electron theory explains very well the conductivity of metals. Hence, we can say the conductivity of copper is not only due to the number of electrons that is present, but it also depends on the material property. It also depends on the effective mass of the electron that have been present in the material. So taking those things into consideration, we can really understand that copper is a better conductor than aluminium. Aluminium is a better conductor than that of zinc. So conductivity of any metals can be explained based on these fundamental concepts. Thank you.